On to solving. Now, one of the things I made emphasis upon was that solving involves an equation. You're finding values that satisfy an equation that make it true. So it means finding x or an unknown. If there are one or more, you have to find the unknown. So this is solve each quadratic equation using the quadratic equation. So I think I did this one in class, but this is again is for those who have missed it, or if you're off and running somewhere else, or just need that review, which is fine as well. We want to remember that there is an A, there's a B, and a C in a quadratic equation. It has to be set equal to 0. So the things about solving with the quadratic formula is you set it equal to 0, you kind of identify your A, B, and C, so you get to ID those, and then you use the equation that is x will ultimately be the solution, the opposite of b, plus or minus the square root of b squared minus 4ac all over, as the crazy clown pops out of his little cave, 2a. So there it is. That's the quadratic formula. What I'll do is plug these values of a, b, and c in there and just kind of talk about the things you want to notice as you're going through this. The opposite of b would be the opposite of 7, which is negative 7, plus or minus square root b squared would be 7 squared. And 4 times a is 2, c is 3. And then all over 2a, so 2 times 2. So I've used the formula. It's plugging in all those values. It's a wonderful thing. The values that we're going to get, the possibilities, you're going to have one solution, two solutions, or no solutions. So when you get done, the results that you get, there's actually kind of a shortcut for discovering that. If you remember, there's this thing right here under the square. It has to do with the square root. What's going on under the square root? That has everything to do with how many solutions you have. For this one, we get 49 on the left, and then 3 times 8, 24. And on the bottom is 4. Starting to look pretty good. And then if I solve it again, negative 7. I'm sorry, simplify it. This would be 25 and 4. We're in good shape. This is going to be a two-solution quadratic, which means graphically, and this is what we looked at in class, it is a graph that crosses the x-axis twice. When you see something set equal to 0 like this, an equation set equal to 0, one of the ways you can determine the solution, it's finding x's such that when you graph this expression, the height is 0. That means you have an x-intercept. It's when it crosses, or it has an output of 0. And we need the x's that make that true. So we call this solving a quadratic equation, also sometimes finding the zeros, finding the roots of this highlighted quadratic equation. So here's what we're going to end up with. We're going to get 2 of them, which means this graph, the parabola, crosses the x-axis twice. And we drew graphs in class to kind of imagine what that looked like. So negative 7 now plus the square root of 25, which is 5 over 4. And that's going to give us 2/4 or 1/2. I'm sorry, negative 2/4 and 1/2. And then at the bottom, if I take negative 7 minus 5 over 4, that's negative 12/4, which we also know as negative 3. Those are our two solutions. The places, if you graph it in, I'm going to do just a real rough graph, but negative 3, 1, negative 1/2, we just know that this graph has roots where it crosses negative 3 and it crosses negative 1/2. Okay. Then over here, this is one where it's not quite ready for the quadratic equation. You want to set it equal to 0 first. And that's a big to-do with the quadratic formula. So I'm going to add x to both sides. I'm going to assume that you're okay with that little algebra move, because that's important to know. You have to add x and add x. Do the same to both sides. It's the rule of balancing equations. It's necessary to keep things from changing the outcome. You keep it balanced. There's an a of 12, a b of 1, and a c of negative 1. Quadratic formula will be just fine. So we go, x is the opposite of b, plus or minus the square root. B squared is going to be 1 minus 4 times 12 times c of negative 1. One of the big things you want to notice is that the quadratic formula, let's point this out, it's really a big deal. Oh, here's our formula. That the division sign goes under all the terms, even the negative b plus or minus. It gets forgotten a lot, so keep an eye out for that. So negative 1 plus or minus, and it's all divided by 2a, which is 2 times 12. Okay, good to keep track of. I'm going to simplify this one relatively quickly. Please let me know if that throws you off a little bit. But this one, the way it works out, if I highlight a few things, let's get the yellow going. It's easier to see. This right here becomes negative 48. And since we're subtracting a negative, it would be like adding 48. 1 plus 48 is 49. And the square root of, plus or minus, the square root of 49 is 7. And that's over 24. It's going to give us one of our solutions. And the second solution will be doing negative 1 oops. Let me take that back. I want to do 1, not both of them at this time, plus this one. And here I'll do negative 1 minus 7, the square root of 49 over 24. Sorry, my cold is just taken off tonight, so as I'm talking, I'm getting more stuffed up. Sounds kind of funny. So negative 1 plus 7 is 6 over 24, and 6 over 24 is also 1/4. And then negative 1 minus 7 is negative 8 over 24, which is negative 1/3. Those are the two places. This particular expression has two solutions, two x's that satisfy this equation. But if you were to graphically look at this little quadratic set equal to 0, it's also where it crosses the x-axis in the graph of what I just highlighted, 12x squared plus x minus 1. It has both meanings. It's the x that satisfies the equation. Graphically, it's where it crosses the x-axis. They're both important interpretations. All right, that's solving quadratics.